Welcome back, class. Today we're going to talk about how to use a multiplication grid to help us understand equivalent fractions. This is just another step for us to visually see what equivalent fractions mean. We've used the picture form. We have tried cross multiplication, and now I'm going to review with you how we use the multiplication grid. This is another step before we get into the abstract of actually multiplying the numerator and the denominator by the same digit to get an equivalent fraction. So let's start with, let's pick a fraction. Let's say we're looking for a fraction that is equivalent to 2/3. So here is 2/3. Now what I'm going to do is I am going to highlight 2/3 on my multiplication grid. Okay, here I have highlighted the numerator in pink and the denominator in yellow. Now if I notice along the line, the pink line, all of these numbers up top are all multiples of 2. And the numbers in the yellow area are all multiples of 3. Well, in essence, when we start looking at fractions and making equivalent fractions using the multiplication of the top number, the numerator, and the bottom number, denominator, by the same number, we are going to be able to get another fraction. But right now, just a visual, this is just for visual so that we can see. Every number along the top and bottom put together create a fraction. So in essence, this is 4/6. Well, 4/6 is equivalent to 2/3, just as 6/9 is equivalent to 2/3, and 8/12 is equivalent to 2/3. All of these numbers together create a fraction. The pink is the numerator, the yellow is the denominator. So any of these numbers that fall along these two lines are equivalent to 2/3. Well, let's pick one and try it out using cross multiplication to check our answer. Let's use 8/12 just so that I can show you that this fact, in fact, does work. 8/12. Okay, we're going to use cross multiplication just like we've done before. Whereas 8 times 3 is 24. And 2 times 12 is 24. Pardon the mess, I'm using the mouse instead of pens. So 24 and 24. 2/3 has the same value as 8/12. Therefore, according to our multiplication grid, 8/12 is in fact equivalent to 2/3. Let's try another one. Let's try one that's a little more spread out. Let's try 9/24. Now, I know that's kind of a high fraction, but it is possible to be able to find equivalent fractions with high denominators with using a multiplication grid without cross multiplying. So now I'm going to highlight the numerator in pink and the denominator in yellow. Okay, you'll see that this time the pink and the yellow are separated. They're farther apart than the first example. But still, again, I have 9 as the numerator and 24 as the denominator. Okay, so looking along the pink line, which is highlighted as the numerator, and the yellow line, which is highlighted as the denominator. Okay, so we have 9/24. Well, anything on the top is an equivalent numerator, and anything on the bottom is an equivalent denominator. You can work forward or backwards. In the last example, we worked forwards. We used the next fraction that was to the right. I'm going to work backwards. I'm going to say that 3/8 is also equivalent to 9/24. So we're going to put 3/8 here, and then we're going to cross multiply just to check, just so that I can prove to you that using the multiplication grid will help you understand equivalent fractions without cross multiplying. If you could visualize the multiplication grid or draw it out and fill in the numbers, equivalent fractions will start to come easy to you, especially when we start the algorithm. You'll start understanding why we multiply the top number and the bottom number by the same number. Now we're going to multiply 8 times 9. Well, 8 times 9 is 72. Again, if you don't know that, here's your multiplication chart. It shows you 72. So 9/24 is equivalent to, has the same value as 3/8. And that's how you use a multiplication grid to help you see, visualize equivalent fractions without using cross multiplication, or if you did not have a visual representation through a picture. I hope that was helpful. Until next time, happy math!